The following video is intended as a supplemental resource for the Durham Tech Math 115 Mathematical Models course. This is video 2 in this series. This video will cover topics of graphs, functions, and linear systems. Additional information on these topics can be found within the course textbook, Thinking Mathematically, 4th edition by Robert Blitzer. Prerequisites. Did you know, during his lifetime between 1596 and 1650, French aristocrat René Descartes developed a new branch of mathematics.
He invented graphing, people.
The rectangular coordinate system is represented in a two-dimensional plane with 4 quadrants. The top right quadrant is quadrant 1. Top left is quadrant 2, bottom left is quadrant 3, bottom right is quadrant 4. Each point in the rectangular coordinate system corresponds to an ordered pair of real numbers in the format of x, y. We plot or locate the points of the ordered pair by counting their distance from the origin. The origin is where the x and y coordinates meet. The first number is the x-coordinate. The second number is the y-coordinate. The x-coordinate denotes the distance and the direction from the origin along the x-axis. This is the horizontal line. And the y-coordinates denote the distance and direction from the origin along the y-axis, or the vertical line. In order to plot points in a rectangular coordinate system, we must know a few basic rules. A negative x-coordinate is located to the left of the origin, and a positive x-coordinate is located to the right of an origin. A negative y-coordinate is located below the origin, and a positive y-coordinate is located above the origin. Alright, so with that understanding, let's plot the following points for x and y. You'll notice below I have provided a list of xy origin points. When we go to plot these points, we're always going to start with the x-coordinate and then the y-coordinate. So in our graph here, we're going to plot this first point, negative 4x and positive 4y. So starting at our origin, the first thing we have to do is go to the left 4 spaces. So that's 1, 2, 3, 4. And now we have to go up because the y is positive 4 spaces. 1, 2, 3, 4. And this is where we place our point. Alright, so let's move to the second one. Alright, so now that we understand how to plot points in a coordinate grid, let me dive into graphing equations. So a relationship between two quantities can sometimes be expressed as an equation in two variables, such as y equals x minus 6. When the x-coordinate is substituted for x and the y-coordinate is substituted for y in the equation, we obtain what is considered a true statement. So let's start with x. We're going to let x equal 1. So in the equation where y equals x minus 6, we have to compute for y. Well, we know that x is 1, so y is equal to 1 minus 6, which makes y equal to negative 5. Okay, so we know that x is 1 and y is negative 5, but we still have to form the ordered pair in order to develop the graph. So our ordered pair is going to be x comma y, and so what we want to do is substitute the x value for the x place, which is the 1, comma, and we just obtained our y value, which is negative 5. So 1x and negative 5y is a solution for y equals x minus 6. So that may be a little confusing, but we'll go through it again. Alright, so having been provided the x value and solving for y, we can now plot the points on our graph. So the first point here we had from the previous example is y equals x, which is 1, minus 6. That makes y equal to negative 5. So our ordered pair is 1, negative 5. You go over one place and then down 5, you end up at the point indicated. The next one is Alright, so an important thing to note here is that we can generate as many ordered pair solutions as desired for an equation by substituting numbers for x and then finding the corresponding values for y. So if I give you the following table, can you solve for y in the equation where the x values are given? Alright, now that we have the ordered pairs, let's plot them one more time on the graph. So part of the beauty of the rectangular coordinate system is that it allows us to see formulas and visualize the solution to a problem. So in this example, we have all of the values for x from -3 to +3, and the ordered pair that we solved for y. So in the equation of y equals x squared minus 1, where x is from -3 to +3, we have the ordered pairs listed below. So let's plot them. Alright, so let's look at a real-world example of how to actually graph an equation. So Costco charges $55 for their yearly membership. Let's suppose that members who use Costco stores save on average about 27.5% on their purchases. The cost of purchasing products with or without Costco membership can be represented by two equations which can be graphed. The purpose of creating such a graph would be to visualize at what point the cost of membership would be paid for by the savings experienced through the purchases. So if you spend $100 each time you go to the store, how many trips would you have to take to Costco before the savings paid for the membership? Okay, so if you spend $100 each time you go to the store, how many trips would you have to take to Costco before the savings paid for the membership? You can see that without the membership, each trip to the store will cost you $100. With the membership, each trip to the store will save you $27.50. The graph shows that 2 trips to the store will cost you $200 with or without the membership. This is the intersect point. Each additional trip to the store to Costco will save you $27.50. Hope you feel like you've learned a little something about the rectangular coordinate system and how to plot points and equations within the system. In summary, the rectangular coordinate system is represented as a two-dimensional plane. It is formed using two numbered lines that intersect at right angles at their 0 points, also referred to as the origin, which divides the graph into 4 quadrants. Each point in the rectangular coordinate system corresponds to an ordered pair of real numbers in the format x, y. The graph of an equation in 2 variables is a set of all points whose coordinates satisfy the equation. For additional information regarding graphs, functions, and linear systems, please refer to your course assigned material. You can also refer to Robert Blitzer's book, Thinking Mathematically, the 4th, 5th, and 6th editions, on Chapter 7. You can also find interactive problems and answers which relate directly to this book at the website interactmath.com. That concludes our video 2. We'll see you as part of video 3. Good luck.